Hello dear students, I am Rana Kumar, your physics faculty at Aakash, and a very warm welcome into another session in which again we are going to discuss the problems of AIATS plus phase 2 mock test 2 that was conducted on 26th of January 2025. And in this session I will be taking the problems on the chapter of electric charges and field, electrostatic potential and capacitance, units and measurement, motion in a plane, mechanical properties of fluids. So these are the topics that we are going to discuss in this session, right? And let's head towards our first problem. And there is your first problem right in front of you. The problem is problem 19 in the original paper, and it is based upon the chapter of electrostatic potential and capacitance, right? So the problem says that n identical capacitors are connected in parallel to a potential difference V. So n number of capacitors, they are connected in a parallel combination to a potential difference V. These capacitors are reconnected in series. Now the capacitors are reconnected in series, and the condition is that the charges are being left undisturbed. So the key point or the keyword I say over here would be that the charges are being left undisturbed. Okay, so we need to find the potential difference obtained. Okay, so dear students, we all know that for a parallel combination of capacitors, I am talking, for a parallel combination, the potential difference remains same and charge is different. Charges are different. Right? Now we can also say that for series combination, the charge is going to remain same, but the potential difference is going to vary. So charge same, but potential difference varies. Now these are some of the key concepts that you need to keep in mind while solving this problem. Now the problem says that the capacitors are connected to a potential difference V. So each of the capacitor that is connected, it will have a potential difference across its plate to be equal to V. Let me assume that the capacitance of a single capacitor is C. So the capacitance of a single capacitor is C, and the potential difference maintained across the capacitor is V. So the charge on the capacitor, it becomes CV. So charge on one of the capacitor, it becomes CV, right? Now these capacitors, they are connected in series, but the charge is left undisturbed. So when they are connected in series, the charge on one capacitor, it will be CV only. And in the series connection, the charge is going to remain same. So charge on all the n number of capacitors, they are going to be equal to CV only. And this is Q total, that is equal to CV. And since they are connected in series combination, so equivalent capacitance will be equal to C by N. So potential difference will be equal to Q total by C equivalent. Right? So what is Q total? It is CV over C by N, that is equal to N times of V. N times of V, right? That means the correct answer to this problem should be option 3. Right? Now we can approach this problem by another method also. The charge on one of the capacitor, was CV, right? Charge on one of the capacitor was CV, and the capacitance was C. So potential difference across one capacitor will be equal to CV by C, that is equal to V. So net V net, total potential difference, will be equal to V1 plus V2 plus V3 and so on. So it will be equal to n times of V. So V net is coming out to be equal to n times of V. I hope you understood the problem. And if you understood the problem, let's move towards a problem. And this is a problem that you guys should attempt. And if you are able to solve it, then put the answer in the comment box. The problem says that n identical capacitors are connected in series. Now, the capacitors are connected in series to a potential difference V. These capacitors are then reconnected in parallel. So first they are connected in series to a potential difference V. These capacitors are then reconnected in parallel, their charges being left undisturbed. The potential difference obtained is. Now, you need to solve this problem, right? And put the answer in the comment box if you are able to find the answer. Till then, I'll try to solve the problem for you. I'll try to solve this problem for you. So n identical capacitors, they are connected in series to a potential difference of V, right? So they are, let me assume that the capacitance of one of the capacitor is C, right? So there are n number of capacitors and potential across all the capacitors is V. So potential difference across one capacitor, it will be equal to V by N, right? So the charge on one capacitor, Q1, it will be equal to CV by N, right? Now they are connected in parallel with charges being left undisturbed. So now the charge again, it will be equal to CV by N only. And capacitance of each is C. So potential difference, it will be equal to Q by C. So CV by N upon C, that is equal to V by N. So potential difference across one or any, it will be equal to V by N, because in parallel combination the potential difference is going to remain same. So the potential difference is coming out to be equal to V by N, which means that the correct answer to this problem will be option 3, that is V by N, right? So I hope you understood this problem. Anyone in the comment box who got the answer? Okay, comment box is all dry. Everyone is sleeping after the lunch. Let's head back to the, let's move forward to the problem, this problem. And this problem is based on the chapter of electrostatic potential and capacitance, which was problem 36 in the original paper. It says that in the electric field of a point charge Q, which is kept at point O, a certain charge is carried from A to B. So the charge is carried from A to B and from A to C. If work done from A to B is W1 and from A to C is W2, then we need to compare W1 and W2, right? And OA is equal to OB is equal to OC. So let me take this as R, this as R, and this as R. Okay. Now, dear students, the electric field, okay, dear students, the electric field due to a point charge, electric field due to a point charge is given as KQ by R square. I'm writing only the magnitude. And the potential due to a point charge is given by KQ by R. So the field in the problem that we are dealing with is, the field is of the point charge, and the potential due to a point charge is given by the expression KQ by R, right? So it means that potential depends on the potential varies with the distance in this manner. Now, at point A, the potential will be equal to KQ by R. At point B also, the potential will be equal to KQ by R. And at point C also, the potential will be equal to KQ by R. I'm talking about the electric potential. So now you tell me what should be the work done as the charge is carried from point A to point B. See, the work done in carrying the charge from point A to point B, will be 0 because there is no potential difference. Since the potential difference is 0, no work will be done in moving the charge from point A to point B. If I talk about the work done in moving the charge from point B to point C, again, potential at B and C, they are same. Again, no work is done. No work is done in moving the charge from point B to point C. And you know, work done by this electrostatic force can be written as minus delta U, which can be further written as minus Q times of delta V, where delta V is change in potential. So if the change in potential is 0, so the work done will be 0, right? So this, based on our analysis, the correct answer to this problem should be option 4, that is W2 equal to W1 equal to 0. It is a very simple concept. No potential difference, no work would be done in moving the charge from point A to point B. Had there been a certain potential difference, we would have then calculated the amount of work done. But the basic concept, basic necessity is that potential difference should be there. Okay. Now, if you are thorough with this problem, let's move forward, and there you go. Okay. Problem 20 based on Gauss law or electric charges and fields. It says that the electric flux through a spherical surface S, containing a point charge Q at its center is phi. If surface area of the sphere is half, then the flux through it is. So this time the electric flux through a spherical surface S containing a point charge at a center is phi. Now surface area of the sphere is half. Dear students, from the Gauss law, what do we know from the Gauss's law? We know that closed integral of E dot ds, it is equal to Q enclosed divided by epsilon naught. So the flux of the electric field, it depends upon the total charge enclosed by the surface. Now, dear students, in this problem, I am reducing the surface area. But even in that case, the charge enclosed by that surface will still be Q. Suppose that this is my closed surface and it encloses the charge Q, right? It encloses the charge Q. Now I am changing the surface area. Suppose that I change the surface area. I make it something like this. Again, it is enclosing the charge Q. So what is the difference? There is no difference. The electric flux will still depend upon the charge enclosed by the surface. And since the charge enclosed by the surface is not changing, there should not be any change in the electric flux through it. So electric flux, if phi is equal to Q enclosed by epsilon naught, it will still remain, after changing the surface area, it will still remain Q enclosed by epsilon naught only. So correct answer to this problem is that the electric flux is not going to change. So correct answer would be option 2, right? Correct answer is option 2. That is a concept that you need to keep in mind while dealing with such problems. Now, a slight variation could be given in the question if I change the charge enclosed by the surface. If I somehow change the charge enclosed by the surface, then there would be definitely change in the electric flux, but not with the surface area, right? Now, if you're thorough with the concept, let's move forward to another problem. Okay, now dear students, okay, someone, hello sir, MD cat ka please padhao, MD cat. Okay, I'm not getting your comment. What are you trying to say? Please write it in a better way. This is a problem and it is an assertion reason type based problem, a very good problem, and a lot of students, they get confused in such problems. In the following question, a statement of assertion is followed by a statement of reason. So obviously you are very well aware with this format, assertion and reason. So you have to see whether assertion is true, reason is true, and whether they are the correct explanation or not, right? So let me go through the assertion first. It says that uniform circular motion is an unaccelerated motion. Good afternoon. So dear students, the assertion is saying me that uniform circular motion is an unaccelerated motion. Now, if I try to solve this problem, I can recall from the fact that in any kind of circular motion, the velocity is going to change its direction continuously, right? So velocity being a vector quantity, it has magnitude and it has direction, right? Now, if I keep the magnitude fixed, but I keep on changing the direction of the velocity, in that case, acceleration will still be there. Why? Because the direction is changing. And so the direction is continuously changing. If I am talking like this. If this is my circular path and particle is, suppose that this is a particle moving in this sense, right? A particle is moving like this. So at this point, the velocity will be in this direction. I'm talking about the uniform circular motion. And at this point, the velocity will be in this direction. At this point, the velocity will be in this direction. At this point, the velocity will be in this direction. V, V, V. Now, dear students, you can very well see that the magnitude is same, but the direction is changing, and the acceleration responsible for changing the direction is centripetal acceleration. So obviously, uniform circular motion is an accelerated motion, not an unaccelerated motion. So this one is wrong because it should be accelerated. Right? So assertion is wrong. Now let's talk about the reason. Velocity remains constant in uniform circular motion. Dear students, velocity, if velocity has magnitude as well as direction, right? So in uniform circular motion, the magnitude is fixed, but the direction is continuously changing. And if the direction is continuously changing, if you are continuously changing your direction of a vector, how can you say that the velocity is constant? It is a false statement. Velocity cannot remain constant because direction is continuously changing, right? So what should remain constant? A better word over here should be, so see, first of all, this is wrong, and in place of velocity, it should be speed. The speed remains constant in uniform circular motion, not the velocity. So so speed remains constant. So assertion is also wrong and the reason is also wrong. Now let's move towards the option. So this option is wrong because they say both are true. This one is also wrong because they say both are true. It says that assertion is true, reason is false. This one is also wrong. Both assertion and reason are false statement. Obviously, the correct answer to this problem is option 4. So in any kind of circular motion, either it is uniform or either it is non-uniform, the velocity is going to change, but the key difference over here is that in uniform circular motion, the speed of the particle remains constant, while in non-uniform circular motion, even speed doesn't remain constant. The speed will also change in non-uniform circular motion along with velocity, but the velocity is going to change in any type of circular motion, right? So I hope you are clear with this. Let's move forward to the next problem. Okay, a problem based on the chapter of mechanical properties of fluids, and it is a problem based on the velocity of efflux. Let me go through the problem. It was problem 5 in the original paper. It says that water is filled up to a height h in the container. A small hole is created at the bottom of a container as shown. Assuming hole area is very small, you need to find the speed of efflux. Okay, so dear students, let me apply the Bernoulli equation for you. This is my point 1 and this is my point 2. I'll apply the Bernoulli equation at point 1 and at point 2. Let me take the area as small a over here and let me take this area as capital A. If anyone knows the answer, you can put the answer in the comment box. Till then, I'll try to solve it. Let us apply the Bernoulli equation between point 1 and 2. This is the form for the Bernoulli that I'm going to use. Okay. So at point 1, the pressure is atmospheric pressure. So I can write that. I am taking this as my datum also. So I am taking this as datum. So at point 1, I can write that P ATM by rho g plus V1 square by 2g, and the height difference is h. It should be equal to P ATM. Again, at point 2, the pressure is P ATM. So P ATM by rho g plus V2 square by 2g, and the height is 0. Right? Yes, someone has commented the answer. So these are the common terms. I'll cancel this out. Now, I know that this area A, it is much greater than the small area A, and based upon the continuity equation, A V1, it should be equal to A V2. So based upon these two, I can write that V2 is much greater than V1. So we'll ignore this. So based upon this, I can write that H is coming out to be equal to V2 square by 2g, or from here I can write that V2 is equal to under the root of 2gh. You can remember this expression, and I don't think there is any problem in remembering the expression. And even if you forget, you can still use the Bernoulli's equation to find the answer. These are some of the assumptions that you need to keep in mind to get to the velocity of efflux. So velocity of efflux, it is equal to root 2gh. So this one is wrong, this one seems correct, this one is wrong, and this one is also wrong. Right? Okay. Now if you are clear with this problem, let's move forward to another problem. There you go. A problem based on the chapter of motion in plane. And it says that a ball is projected at an angle 60 degree above the horizontal with a speed 30 meter per second. After certain time, it makes an angle of 45 degree with the horizontal. We need to find the speed of the ball at that moment. So speed of the ball is the requirement of this problem. So let us calculate the speed of the ball. So such is the projectile motion, right? And a ball is projected at an angle 60 degree. So this is 30 meter per second at an angle of 60 degree with the horizontal. If someone gets the answer, you can put the answer in the comment box, right? Now, dear students, we all know that the horizontal component of initial velocity will be equal to 30 cos 60 degree, which should be equal to 15 meter per second. And it will be equal to 30 sine 60, that is 30 root 3 by 2, that is 15 root 3 meter per second. Now we need to find, thus at certain time it makes an angle 45 degree with horizontal, the speed of the ball. We need to find the speed of the ball at that moment. Okay. Okay, dear students, the key concept over here is that the acceleration along horizontal direction, along horizontal direction is 0, right? So acceleration along the horizontal direction is 0. It means that, okay, someone is commenting the answer. So it means that AX is 0, right? I'll use this concept. AX is 0. It means that V should be, velocity along X direction should remain constant. Suppose that this is the point, not exactly at the highest point, just before that, or at this point P, the velocity V, it makes an angle 45 degree with the horizontal. So the horizontal component over here will be equal to V cos 45 degrees. Right? V cos 45 degrees. Now V cos 45 degree, as the acceleration is 0, it should be equal to 30 cos 60, that is 15. So I can write that V by root 2, it should be equal to 15. So V should be equal to 15 root 2 meter per second. Okay, so 15 root 2 meter per second, that is option 2 should be the correct answer. This 30 is wrong. Not 15 by root 2, it should be 15 root 2. So this one is also wrong and this one is also wrong. So correct answer is option 2. Now dear students, if you have understood this problem, attempt this problem. And this problem says that a ball is projected at an angle 60 degree above horizontal from ground with a speed of 30 meter per second. After a certain time, it makes an angle of 45 degree with the horizontal. The height of ball at that moment is. Now I have done a little bit of modification to the previous problem. Now you have to find that what is the height of the ball at that moment when its velocity makes an angle 45 degree with the horizontal. Now dear students, you can attempt this problem if you understood the previous problem, and you can put the answer in the comment box. Up till then, I'll try to solve the problem for you. So here is the problem right in front of you. This is the projectile motion. This is the initial point of projection, and this is the point at which it makes an angle of, this is V, it makes an angle of 45 degree with the horizontal, right? And this is the 30 meter per second. It is making an angle 60 degree with the horizontal. So you basically need to calculate, this height h. Okay, anyone can comment the answer if you are getting the answer. Till then, I'll try to solve the problem. So in the previous problem, we just calculated that V is coming out to be equal to 15 root 2 meter per second. It means that this Vx, it will be equal to 15, and this Vy, it will also be equal to 15 meter per second. Now we can use the equation 2as, it is equal to V square minus U square, right? 2as equal to V square minus U square, and I'll use this equation in vertical direction. Right? And I'll take upward direction as positive. Anyone getting the answer to this problem? Okay, I'll try to solve. So 2as equal to V square minus U squared, you need to apply this equation in the vertical direction. So I'll solve this for you. So 2 into acceleration due to gravity is in downward direction. So it will be, okay, someone has commented the answer. Let me check. So 2 into minus g. Okay. And let it be h, it is equal to V square. Here V will be equal to 15 square minus U square. What is U? So it was 30 cos 60, that is 15, sorry, not 15, it was 30 root 3 by 2, that is 15 root 3. So it will be equal to minus 15 root 3 whole square, right? So this will become 2 into minus g into h, it is equal to 15 square minus 15 square into root 3 square, that is 3. So I can write that minus 2gh, it is equal to 225 into minus 2. So I'll cancel this minus and minus. So h becomes 225 into 2 by 2 into 10. So this 2 and 2 cancel. So the value of h is coming out to be equal to 22.5 meters. So this is the height of ball at that very moment when it was making an angle of 45 degree with the horizontal, and the correct answer to this problem is option 3, that is 22.5 meter. Yes, very well, if you have got the answer. It was a slightly difficult problem as compared to the previous one, but since you are clear with the concepts, you can easily find the answer. So dear students, I hope this problem was clear to you. Now let's move forward to another problem. Okay. Again, a problem based on the chapter motion in plane, and the topic is projectile motion. This time it says that the velocity of ground to ground projectile at the point of projection is 5 I cap plus 10 j cap meter per second. The time of flight of the projectile will be. So you have been given that the velocity at the point of projection, that is 5 I cap plus 10 j cap. You need to find the time of flight of the projectile. Anyone comment the answer if you are able to find it? So I'll discuss the concept with you. Okay, I'll discuss the concept with you till then. See, velocity at the point of projection, it is equal to ux I cap plus uy j cap. What is ux and uy? Ux is horizontal component of initial velocity and what is uy? Vertical component of initial velocity. Vertical component of initial velocity. Right? So what is time of flight? Time of flight, the correct expression or the formula for time of flight is 2 into uy by g. Right? So 2 into uy by g. Now, dear students, we very well know that 2 by 10, and what is the value of uy? You can compare it, it is 10. So it is coming out to be equal to 2 seconds. Correct answer becomes the option 1. So the correct answer to this problem is option 1. That is 2 seconds, 1 second, 4 seconds, and 3 seconds are wrong. Now, dear students, if you understood the problem, help me find out the range, this range of the projectile. What should be the range of the projectile if the initial velocity of projection is 5 I cap plus 10 j cap meter per second. Anyone, if you are able to find out the range, put the answer in the comment box. Till then, I'll find the range for you. So range denoted by R, it is equal to ux into 2 uy by g, or you can tell it to be ux into time of flight. Okay, yes, someone is commenting. So R will be equal to ux, that is 5 into 2, that is 10 meters. Okay, if you are able to find the range, help me find out the maximum height, h max. How to find the maximum height? Anyone can put the answer in the comment box, h max. So I'll write the expression for the h max. If someone knows, they can put the answer in the comment box. H max is given by uy square by 2g. So what is uy? Uy is 10. So 10 into 10 by 2 into 10. 10 and 10, 2 and 10. That is 5 meter. We calculated the range, we calculated the maximum height. Give me the angle of projection from the horizontal. If the angle of projection, suppose that the projectile was projected with a velocity, so u at an angle theta with the horizontal, what should be the value of tan theta? If the initial velocity of projection is 5 I cap plus 10 j cap meter per second, what should be the value of tan theta? Anyone can put the answer of tan theta. What should be the value of tan theta? So till then, I'll try to solve this. So this one is ux and this one is uy. This one is ux, this one is uy. So if I try to solve this, tan of theta, it should be equal to uy by ux. So what is uy? Uy is 10, ux is 5. So it is equal to 2. So tan of theta, it is coming out to be equal to 2, or theta can be equal to tan inverse of 2. So see, yes, tan inverse 2, very good. So see, with the help of one problem, you can find out so many things if initial velocity of projection is given to you. So I hope you are clear with such problems in which you are given the initial velocity in the vector form. You can find out the time of flight, you can find out the range, you can find out the maximum height, even you can find out the angle of projection also, right? Now let's move forward to another problem. Okay, there you go. You have the problem in front of you. If someone wants to attempt, they can attempt and put the answer in the comment box. And till then, I'll go through the problem. And it was problem 18 in the original paper. It says that an electric field is given by E vector. And this E vector is given as I cap plus 2j cap plus k cap Newton per Coulomb. The work done in moving a unit Coulomb charge from Ra, that is 2I cap plus 2j cap, to Rb, that is 4I cap plus j cap meter is. So dear students, we need to find it. Okay. So work done. Work done can be defined as the dot product of force into displacement, F dot S. Right? I hope you are clear with this. So it is very much easy to calculate the displacement vector. It will be equal to RB vector minus RA vector. So what is RB? RB is 4I cap plus j cap minus RA is 2I cap plus 2j cap. So it becomes 4 minus 2, 2I cap, j cap minus 2j cap is minus j cap. So the position vector S vector is coming out to be equal to 2I cap minus j cap. The question is how to find, okay, someone is commenting the answer. The question is how to find minus 4j cap. Someone has commented the answer as minus 4j cap. Let me solve this. Minus 4 joule, sorry, minus 4 joule. So how to find the force vector? So if a charge particle is placed in an electric field, it will be equal to QE, Q times of E vector. Now the charge is a unit Coulomb charge. So F vector will be equal to E vector because Q is equal to 1 Coulomb, right? So S vector we need to find E vector, I cap plus 2j cap plus k cap. So E vector is equal to E vector, that is equal to F vector, it is equal to I cap plus 2j cap plus k cap, right? So we need to do work done, that is equal to, sorry, we just need to do E dot S. So E dot S, I'm doing it. So I cap plus 2j cap plus k cap. Its dot product is 2I cap minus j cap. So it is 2 minus 2 to be equal to 0. Okay, someone was commenting answer as minus 4 joule. I am getting the answer as 0. So it means that the correct answer should be option 4. So 8 joule, 4 joule and minus 4 joule, they are wrong. So I hope that the student who got the answer as minus 4 joule, you are clear that where did you go wrong while attempting such kind of problems. And I hope that this problem, I made it clear to you how to attempt such kind of problems. Okay, someone is again commenting minus 4j cap. I guess not, it's not minus 4j cap. It is 0. Any doubt you are having in this problem? If you are getting any doubt, you can put it in the comment box. Okay, the problem is clear. Let's move forward to another problem, and there you go. Problem 21 of the original paper based on the chapter of electric charges and fields. It says that if 10 raised to the power 16 electrons are removed from a neutral metal sphere, then the charge on the sphere will be. Okay. First of all, tell me, what is the charge associated with the electron? What is the charge associated with the electron? Anyone can put the answer in the comment box. What should be the charge associated with the electron? Anyone put the answer in the comment box if you know what is the charge associated with the electrons. So 1 electron, it is equal to 1.6 into 10 raised to the power minus 19 Coulomb. Now dear students, 10 raised to the power 16 electrons are removed from the neutral metal sphere. Now if you are removing the electron, then the sphere will be positively charged or negatively charged. Well, if you are removing the electron, okay, someone is commenting the answer. While if you are removing the electron from a neutral metal sphere, definitely the sphere is going to get positively charged, not negatively charged. Because you are removing the negative charge, it means that the positive charge is going to increase. So definitely the sphere is going to be positively charged. So the answer cannot be negatively charged. So all the options which says that it is negatively charged should be wrong. So I have nullified two of the options just by going through the basic concept that option 2 and 4, they cannot be the answer to this problem. So the option, either the correct one should be either 1 or 3, right? Now, charge on the electron is 1.6 into 10 raised to the power minus 19 Coulomb. You have removed 10 raised to the power 6 electron. So that means that the charge removed, the negative charge removed is 1.6 into 10 raised to the power minus 19 into 10 raised to the power 16. That means it is 1.6 into 10 raised to the power minus 30. Sorry, minus 13. It is 1.6 into 10 raised to the power minus 3. This much charge, sir, remove means loss of electron. Why positive? Since you are removing the electron, you are reducing the negative charge, so definitely the positive charge is going to increase. Initially, the number of positive and negative charge were same. Now you have removed the negative charge, so you can understand that the positive charge number has increased. So obviously, the metal sphere is going to get positively charged. So yes, this much charge is removed. That means that the charge on the sphere, is positive of 1.6 millicoulomb. This should be the charge on the sphere. One, yes. The correct answer to this problem is option 1, that is 1.6 millicoulomb, right? Now if you're clear with this concept, tell me that if I am removing the electron, whether the mass of the sphere will increase or decrease. I'll repeat my question. It says that if I'm removing the electron from the neutral metal sphere, the mass of the sphere, whether it will slightly increase or slightly decrease, or it will remain same. Anyone can put the answer in the comment box. First one says slightly increase. Second one says slightly decrease. Third one says remain same. Okay, someone is telling decrease. Yes, if you are removing the electron from the neutral metal sphere, it means that you are removing some mass also. So overall, the mass of the sphere is going to decrease. However, if you were adding the electron on the sphere, in that case, the mass will be, the mass is going to increase. But if you are adding the electron, the final charge on the sphere will be negative. And if you are removing the electron, the final charge on the sphere will be positive. So yes, it will slightly decrease, right? Okay. If you are clear with this problem, let's move forward to the next problem. It says that, there you go, your problem 42 of the original paper. It says that a bubble is charged to a potential equal to 6 volt. If its radius is tripled, then the potential of the bubble becomes, okay. Simple problem. I hope, I know that you got confused with the word bubble, right? Because had it been some sphere, solid sphere, shell, you were very confident, and I am very confident you would have answered this problem, but the bubble is problem over here, and this problem is based on the chapter of electrostatic potential and capacitance. Now dear students, the potential on the surface of bubble V, it is equal to K into Q by R, where R is the radius of bubble. I'll use this expression to find out the answer to this question, right? So potential at the surface of bubble is equal to KQ by R. Now, the problem says that keeping the charge same, if you triple the radius, what should be the potential of the bubble? So keeping the charge same, K is going to remain constant. I can write that the product of potential into the radius of bubble, it should remain constant. Right? Okay, someone is commenting the answer. So if initially the potential was 6 and radius was r, let me assume that when the radius of the bubble is tripled, let the potential be v prime and the radius becomes 3r. So let me cancel this r and r. So v prime, it becomes 6 by 3, that is equal to 2 volt. So it means that the correct answer is option 3, that is 2 volt. So 1 by 2, 1 and 18 volt. They are obviously wrong, right? So dear students, it was much evident that for the same charge, if you are increasing the radius of the bubble, the potential is going to decrease, considering we are taking the positive sign. So yes, the potential is coming out to be equal to 2 volt. Right? I hope I made this problem clear to you. Now let's head forward to next problem. And there is your next problem. It says that which of the following physical quantities has neither dimensions nor unit? So this time, okay, someone is commenting the answer, very well. So this time we have to find the quantity which has neither dimensions nor unit, right? And the first quantity right in front of you is angle. So all of you know that angle is a dimensionless quantity, but angle do have a unit. What is the unit of an angle? Can anyone put the answer in the comment box? Angle, it is dimensionless, but it has got unit that is equal to radian. And if it is a solid angle, the unit will be steradian. But yes, angle is a dimensionless quantity, but it has got unit which is radian. So we have to find a quantity which has neither dimensions nor the unit. It is dimensionless, but it has got unit, so it cannot be our answer. So this one is wrong. Let's talk about the second option, coefficient of friction. Dear students, coefficient of friction, it is a dimensionless quantity, you all know that, and it is a unitless quantity also, right? So we all write that F is equal to mu into N. So mu is F by N. So it will be dimensionless as well as unitless. So this can be our answer, but we need to check all the 4 options before getting to the final answer. The third one says that gravitational constant. Dear students, gravitational constant, it is given by the expression F equal to G m1 m2 by r square. So definitely the gravitational constant will have dimensions. It is going to have dimensions and it is also going to have units. Dimensions and unit as well. So yes, gravitational constant cannot be our final answer to this problem. So this one is also wrong. Let's talk about stress. Stress. What is the unit of stress? Anyone can put the answer in the comment box. What is the unit of stress? It's Newton per meter square. So it has got a unit. Let's find out the dimension. So it is ml t minus 2 by L square. So it becomes ml minus 1 t minus 2. So stress, it got unit and it got dimensions also. So there is a unit as well as there is a dimension, which means that the stress cannot be the correct answer also. So the correct answer to this problem is coefficient of friction, that is option 2. I hope I made this problem clear to you, right? And if there is any doubt, you can put the doubt in the comment box, or you can always contact us, right? So dear students, with this, I'll close my session. Of this discussion, and I hope you found the discussion very fruitful. All the concepts and the queries, I made it clear from my end, and I try to make it clear from my end. If If there are any queries left, you can always contact us. You can always contact us, and we will be available, and we'll try to resolve the query, right? And for the time being, I'll be signing off, and all the very best for your upcoming examinations. Take care of your health and prepare well. Thank you.